Continuing with the topic class hierarchies and inheritance. Okay, we will learn more about inheritance later in the course, but here is just a sort of preview. As we start modeling of different classes, we should consider how these classes compare to one another. By identifying commonalities, we can organize a class hierarchy. Okay. For example, look at student class, and professor class. Student has name, phone number, birth date, course schedule, advisor, transcript, declared major. These are the variables for a student. Professor has name, phone number, birth date, course schedule, department, office and office hours. Student has methods: get name, get phone, get set phone number, get age, get major, declare major, enroll a course, drop course, get grade course, assign grade for the course of that grade, has taken a course, check graduation, get GPA. Professor has methods: get name, get phone, set phone number, get age, get office, set office room, get department, get office, add hours time, remove hours time, assign grade for a course or for a student a certain grade. You see, there are some things which are common and some things which are not common. All right. And these methods, by reading them, you realize what they pertain to, okay, what they are used for. For a professor, get office is something important, right? Assign grade is important, whereas for a student, assign grade, course, grade. So, can for this student assign this course, in this course, this grade, as opposed to when a teacher assigns grades, the teacher has many students, so assign in this course this student a certain grade, and so on. All right. But notice there are commonalities. So let's maybe arrange these. It's a waste of time to code a student with all these attributes and then go again code for a professor and all these attributes when there are certain common attributes to begin with. So here is a hierarchy. Why don't we code a person class, a class called person with the common attributes? What's not common are here. All right. So a person has a name, birth date, phone number, course schedule. Person has methods: get name, get age, get phone, and set phone number. Every person has that. All right. For our, say, college. Now, a student, in addition to these variables, a student has an advisor, transcript, declared major. So, what did we add here? We added only those things which are not here, but you need for every student. In other words, the student will inherit all these attributes and some more. Same way for the methods. A student will inherit all these attributes and some more. Get major, declare major, so on. All right. Same thing for a professor. The professor will inherit these attributes and then have more variables. Professor has a department, office hours. Professor will inherit these methods and then have some more methods. All right. So this is called class hierarchy. This is a parent class. These are two children classes. This is a child class of this. Professor is a child class of person. Note that the person class is more generic class than student and professor classes based on their commonalities. When modeling the student class relative to the person class, a student instance inherits all of the attributes and methods of the person class. Similarly, professor class inherits from person and then additional attributes and methods are specified. The person class, that is a top class, is a parent class or the base class. Person class is parent class of student class. Person class is parent class of professor class. So on. Student class or the professor class is the child class or the sub class of person class. So these two are subclasses of the top class. The top class is called base class, parent class. This is parent, this is a child, this is a child. That is a base, this is a sub, this is a sub. All right. Now, so the relationship between a parent and child class is often termed an is a relationship. Every student is a person, but converse is not true. Every person is not a student. Some of these instances are also professors. So every student is a person, every professor is a person, but the reverse is not true in general, right? Now, notice the difference between an is a relationship and has a relationship. A student has a transcript, course has a professor. In a has a relationship, a class has attributes that are instance. So this might be tricky to understand. A student, you could have another variable here called professor. In other words, a student has professor as a variable. Okay. Likewise, a student can have a class object as a variable. So has a is different from is a relationship. Okay. Here is another example. We'll start on the next video, a drawing package. Okay. Until then.